Hello guys, welcome to A-Level Physics and Mathematics. In this section, like I said, last time we will proceed with an exercise. Here we have exercise 2.1 from grade 12 physics. So exercise 2.1, question 3, it says that a ball is thrown from horizontally with a velocity of 20 meters per second from top of the cliff or top of the building with a height of 90 meter, and then calculate the following terms, which is time taken as well as horizontal displacement, and then the resultant velocity of this ball. So before I proceed to this session, could you please subscribe, share, and then like this video, or then that will help me to make another video as well. So let's proceed with the exercise. So before calculate this exercise, what you need to do is you need to understand the given terms that that will help you to calculate the given exercise. So we have initial velocity, which is basically let's describe first of all the whole scenario of the ball. We have a building. We have a kind of building which is, it looks like this, and then the ball is thrown from this building. The ball is thrown from this building with the height of 90 meter. Basically, this is a maximum height, but the thing is the height of building is given. So which is y is equal to 90 meter, and then the velocity, or basically this is the initial velocity of the ball, meaning that the initial horizontal velocity of the ball, which is v naught x, which is equal to 20 meter per second. And then we have also v. We need to basically understand the v, the horizontal and the vertical component as well. So the vertical component is basically it's v y naught, which is equal to 0 meter per second. And then we have also acceleration due to gravity. You can see in the exercise, you can get that the acceleration due to gravity from the book, which is it's given basically which is 10 meter per second squared. So these are the given term. Let me write over here for you guys so that you can understand. This is basically a basic scenario of this ball. So we have, like I said, we have a given term which is v naught x is equal to 20 meter per second. V naught y is equal to 0 meter per second, and then the y is equal to 90 meter, as well as acceleration due to gravity is equal to 10 meter per second squared. So 10 meter per second squared. This is a given terms that will help you to calculate the given exercise. So the required term is with a is equal to the time taken, or a is time taken is a required term, as well as x. This is b. X is equal to you need to calculate x as well, which is a horizontal displacement basically, and then resultant c is resultant velocity, which is v is equal to or you need to calculate the resultant velocity. So to calculate to calculate the a, we need to find out the appropriate equation that will help you to calculate the time taken to this exercise. So what you need to do is from projectile motion, as you know, projectile motion equation, you know that v y naught is equal, v y naught plus 1 upon 2 gt squared. This is a basic equation that will help you to calculate a time taken. So before that, we need to we need to know basic terms, which is we don't have time in this given. So what we need to do is we need to know how to find out the time. So basically, you can drive this equation from the kinematics equation, which is from basically as a uniform motion or kinematics equation. So from uniform motion, you can get let's say from uniform motion, as you know, if an object is moving with a uniform motion, you can find that average velocity is equal to initial velocity plus final velocity upon 2, as well as change of v, change of x is equal to average velocity time t, and then final velocity is equal to initial velocity plus acceleration time, right? So we can rearrange this basic uniform motion equation. So from this you can replace or you can plug this equation over here. Therefore, change in x is equal to initial velocity plus final velocity plus or final velocity upon 2 time with time, right? So change in t is equal to, and then final velocity means you can replace final velocity with this equation as well. So when you plug this equation over here, we can get plus initial velocity plus what was that? The next term is a time t, right? And then over 2 time, right? So changing t, changing x is equal to, you can get 2 v initial velocity time at time over 2 time, right? Changing x is equal to, you can get 2, basically you can get like this upon 2 plus 1 over 2 at square, right? So this term is cancelled with this guy, and then we have time basically, and then changing x is equal to what you can get is v initial plus initial velocity time plus 1 upon 2 a t square, right? You can drive this equation using this uniform motion equation. Basically, this is a kinematics equation, right? So you can write it. Basically, this equation and this one is technically they are the same, exactly the same equation. So this is for acceleration. For uniform motion, as well as this one is for projectile motion. The displacement for projectile motion, as well as this guy is for motion in uniform motion. Therefore, what you can do is you can replace this term. You can replace the given term. Now, we have y, which is 90 meter, is equal to this term is basically 0 over here. So 0 plus 1 upon 2 g is equal to 10 meter per second square, right? And then time is the required time. Also time is square, and then g 90 meter is equal to we can get 5, right? 5 meter per second square time right? T square. So what you can do is you can divide it both sides by 5. Therefore, t is equal to t square is equal to 90 meter over 5, right? 5 meter per second square, right? So t is equal to square root of how much? This guy is cancelled by this guy, and then you can get 18 second square, right? So meaning that t is equal to 18 second square is equal to basically right 9 times 2 second square, right? Then t is equal to 3 square root of 2 sec, right? Then what you can do is what you can get is you can get, meaning that which is equal to 4 points, right? 4.24 second, which is time. Then this is time. We did find the time. So this is a solution for time. Then you can calculate also b, which is x, right? B is equal to x, which is equal to horizontal displacement, right? So to calculate horizontal displacement, you need to use a constant horizontal velocity multiplied by time. So horizontal velocity is x is the time is time, which is equal to this term is over here, right? So 20 meters per second time with time is over here, 4.24 second. Let me just double confirm over here. This term is equal to yep, it is 20 seconds. So basically you can confirm by yourself, but this is 4.24 seconds. So you can calculate this term as well. So which is equal to, you will get from here, it is, I think, a t 4.8 meters. So that is, maybe you may check by yourself, but you can get approximately 84.8 meters. That is the horizontal displacement. Okay, that's the horizontal displacement of this ball. So next is the resultant velocity of a ball or a projected ball. So to calculate the resultant velocity, what you need to do is c, right? So c is equal to v is equal to what you need to do is basically you need to use a Pythagorean theorem to calculate the resultant velocity, which is a magnitude. So what you need to do is v squared is equal to vx squared plus vy squared, right? We do have here over y, we do have a vx, right? Vx, because this term is equal to with a vx, right? Vx, because it's a constant horizontal velocity. So that's why I told you you need to use a horizontal velocity, horizontal constant velocity. So which is equal to v with vx. So v is equal to vx means 20 meter per second, right? Vx is equal to 20 meter per second, the whole square, plus vy. We don't have vy over here, as you can see. We don't have vy, right? So to calculate a vy is equal to, you need to use from projectile motion, as you know, to calculate a vy, we can use an equation vy naught, right? Vy naught plus gt, right? So this term is 0. As you can see, we don't have a vy naught. V not y. So which is equal, vy is equal to g is 10 meter per second, 10 meter per second square, right? Then time is 4. I will put a bracket over here, is 4.24 seconds, right? Then vy is equal to we can get, I think, 42 let me just double confirm, 42.4 meter per second. So you can just plug over here, you can plug this term over here. This is a vy, okay? This is a vy, okay? Then vy is equal to 42.4 meter per second, the whole square. So v is equal to square root of what? 20 meter per second, the whole square, plus, and then 42.4 meter per second, the whole square. So v is equal to, you can do this, you can calculate this by yourself. So what you can get is basically you will get 46.9 9, I will say approximate value, but yeah, you will get definitely 46.9 meter per second. This is the final answer. So yep, that is all for today. If you have any question, please feel free to put in the comment section. I'm happy to reply for you guys. We'll proceed. This is, I think, exercise 2.1. From exercise 2.1 is question 3. We'll proceed with 4, 5, and extra as well. So like I said, let me know if you have any other question. I'm happy to reply. And then yeah, that's all for today. Could you please share, subscribe, and then like this video? That will help me to make another video as well. Yeah, that's all for today. Have a good day. Thank you.